Okay, function notation just involves these fx businesses or gx businesses or hx businesses. The reason why they were devised is to enable us to talk about algebraic expressions without giving you the details. If I wanted to say that I was thinking of a graph, but I didn't want to tell you the algebra, I could just say that my graph is y equals fx. Now, just because this was invented to avoid having to give you the details doesn't mean we don't sometimes give you the details. And in fact, in GCSE questions, we often give you the details. Whenever you give you the details, I strongly recommend that you actually say out loud what it is that it's doing. So in this example, fx is doubling x and then adding 1. This example here is taking 1 away from x and then squaring the result. And finally, this example here is dividing x by 3 and then slapping a great big square root symbol around it. Now, if you remember to say out loud what these things are, then you can very easily answer little questions like this. So remember, fx is doubling x and then adding 1. So this is doubling 2 and then adding 1. So that's 5. Or this, remember g was taking away 1 and then squaring? So if that's what you do to x, it's what you do to m squared. So what was it? It was taking away 1 and then squaring. Okay, so they're very simple little questions. And finally, we ask you also to work out what's called composite functions, and that's where one works on the results of another. So for example, fgx means that g has a crack on x, and then f has a crack on what g gives it. So the one that works first is the one that's closer to the x. That should make sense. So another example,ghx means that h works on x, and then g works on the results of h. Now often you get asked to say what the resulting expression looks like. All you need to do is use the details. So g has a go at x. What does g involve? Taking away 1 and then squaring. And then what does f do? F doubles and then add 1. So normally f would work on x. It's not working on x now, it's working on this. What does it do? It doubles it, and then it adds 1. What about this? H has a crack at x. What does h involve? Dividing it by 3 and then slapping a great big square root symbol around it. Then what does g do? G subtracts 1 from the expression and then slaps a great big square root around it. So that's what function notation is.